A car is traveling in a straight line at a speed of 30 meters per second, and it passes near a stationary observer while it's sounding its horn. And the horn, the original frequency of the horn is 400 hertz. So we know that 400 hertz of the sound, and the car is moving with 30 meters per second. Right? The observer is stationary. Here's the key point: the observer is stationary, and the speed of sound in air is 336. What is the change in frequency of the sound heard by the observer as the car passes? Okay, so we need to figure out what's the change the observer will observe in the frequency. Okay, now remember, it's a natural phenomena that whenever an object moves while it is emitting some sort of waves, the original wave, the frequency of the original emitted wave will be different observed by the observer. It is going to be higher or it is going to be lower depending on the direction the object is moving towards. So for example, if this is the observer and the car is moving towards the observer, so the observed frequency will be much higher, or it will be higher than the original frequency. Alright, so if in this case it is 400, then observer will receive more than 400 hertz. Or the second case would be if the car is going away from the observer. If the car is going away from the observer, then the frequency will be lower than 400 hertz. But here the case is we actually first need to figure out what is the frequency observed by the observer, and then we need to figure out the change in the frequency, overall change in the frequency. Alright, so this is a Doppler effect, and we are going to use the formula of Doppler effects, which is the observed frequency is equals to the speed of sound in air plus the observer's velocity, or observer's speed divided by speed of sound in air minus source velocity times fs, where fs is the source frequency. Right, let's plug in the values. So f0, which is the observed frequency by the observer, is equals to the original speed of sound in air, which is 336. This is given in the question, plus the speed of the observer. Now here the point is observer is stationary, right? They have mentioned that observer is stationary, so we'll put it as 0 divided by the speed of sound in air, which is 336, minus the speed of the source. Now speed of the source is 30 meters per second, so we'll put it here 30 multiplied by fs. Now fs is the source frequency, which is 400 hertz, the original frequency of the horn, and this f0 will be, this turns out to be 439.21 hertz, right? Approximately 439 hertz. So we can actually calculate the change, because change is what is required in this question. We need to calculate the change in the frequency. So change is the observed. How do you calculate the change? Delta f will be equals to delta f observed minus f source. This is the change. F observed minus fs, right? So in this case, f observed is, which is 439, minus f of the source is 400. So we can say that the frequency, the change in frequency is, it actually turns out to be minus 39 hertz, but since frequency is a scalar quantity, we will definitely go with the, we know that the change is 39 hertz, right? Or you can keep it other way around, like 400 minus 439. And it actually is plus 439. 439 minus 400 is 39 hertz, right? So 39 hertz is the right option, and we need to go with this.